Good morning, good afternoon, guys. I hope you're having a good day so far. It should be Monday, the 28th. You should be on week 6, and this is going to be assignment number 14. We're going to look at some more graphing. It's called Further Graphing, Objectives 1 and 2. Um, I hope you all had a good weekend. I will have just celebrated my birthday, which was on the 26th. I think should be on a Saturday. So I'm definitely missing you guys by now. I hope you guys are enjoying your time there with Miss Escobar, and I hope everything's going okay for y'all. What we're going to do here is we're going to write quadratic functions of the form f of x equals a times parentheses x minus h parentheses squared plus k. So basically all we're doing is taking all three of the transformations that we looked over in assignments 11, 12, 13, and we're putting them together. And we're going to define the formula. There's actually a formula to find the vertex when you have this form. Okay. The question we should be asking ourselves is, what shape does a quadratic function make when graphed? And we will write quadratic functions in the form f of x equals a times x minus h squared plus k. You all are going to rewrite functions and then sketch them and label the vertex. So let's take a look at the definitions and explore some graphs of quadratic functions. Remember, the graph of a quadratic function is a parabola that points upward or downward. And this is the base. F of x equals x squared. Everything is compared to this reference of, excuse me, I got a little bit of runny nose. I ate some salsa right now in Chile. So there's a parabola that's opening upward, or if that a is negative, you can also have one that points downward. Okay. Let's take a look at we need to learn how to rewrite. So we are used to seeing this. Okay, we saw these in quadratic functions, equations, like probably 6, 8 weeks ago now. It would have been right before spring break. So it's been a while, but we're going to refresh our memory and see what we need to do to rewrite this function or rewrite this function in this way. So we're going to go back and forth between the two. So one way to think about it is this. I know that I can take this function and I can graph it using a graphing calculator, or I can try to solve it by factoring or some other method and then plot it that way. Or I can also make an XY table. So all of these methods will work, but there's another thing that I can do is if I can get this and rewrite it to look like this, I'll know right away if it opens up or down. I'll know where my vertex is, and I'll know if it's going to shift from left to right or up and down from this zero origin. So what I'm going to try to do is take this f of x, x squared minus 4x plus 5, and make it look like this so I can rewrite it and kind of get to a solution in a little bit of a simpler way. So the first thing what we need to recognize is I need to get something that looks like this, an x minus a number squared. And the way I can do that is by doing something called completing the square. We learned about completing the square when we were looking at these functions earlier, like I said, about 6 to 8 weeks ago. So the first thing I'm going to do is I remember that f of x is the same as y, okay? We just use f of x sometimes because it helps us define functions. So I'm going to just rewrite this as y equals x squared minus 4x plus 5. And I want to complete the square here. So what we do is we complete the square is I'm going to take this 5 away from both sides. Let me write a different color. Subtract 5. This is just part of the steps of completing the square. If you need to review this process in detail, go back to I don't even remember what assignment it would have been, but it would have been from the last 9 weeks on completing the square. It's on methods for solving quadratic equations. You're going to see why we do this here in a bit. So y minus 5 equals x squared minus 4x. And I'm going to kind of leave this blank here for now. So what I do is I take, remember we take this number, -4, we divide it by 2, always 2 and always squared. -4 divided by 2 squared becomes -2. -4 divided by 2 is -2, and then squared becomes equals 4. So we put that right here. Okay, this goes here. So we've got x squared minus 4x plus 4. And because I add 4 to the left, I have to add 4 to the right. Or because I add 4 to the right, I have to add 4 to the left. This part came from, you take this b term, whatever this number is, you divide it by 2 and you square it. Okay, it was part of completing the square that we already learned. So now I'm going to simplify a little bit. Let me get this. Y equals 4 minus 5 is -1. X squared minus 4x plus 4. And what winds up happening is when I take the factors, which we also learn in methods for solving quadratic formulas, I get x minus 2 times x minus 2. Those are the factors that will give me x squared minus 4x plus 4. And what I can do is I can rewrite this as x minus 2 times x minus 2 is the same as x minus 2 squared. And I'm going to bring this -1 to the other side by adding 1. Okay. Now, guess what? I did all of that work just so I can get it to look like this. Okay. Look, I've got my x squared, so this is going to be, let me do this. That's h, that's k, and in this case our a is right here, which is just 1. So guess what? I know from our previous notes that when I have this form, the vertex equals whatever the opposite of whatever h is, and k will give me my vertex. Okay, so in that case my vertex here is going to be -2, the opposite, so it's +2, and then my k is 1. So I know that I'm going to have a vertex at 2, 1. And I know because a is positive that my parabola is going to open upward. There's one more thing I need here. I need at least one more point. This gives me the vertex, so I know that the bottom of my parabola is going to be here, but I don't know where else or what other points my parabola is going to cross. I don't know what else to do. So I need one more point, and guess what point I can get? I can figure out what my y-intercept is. I can figure out what point my y-intercept is because I know that wherever this parabola crosses, if it crosses up here, or if it crosses up here, or if it crosses down here, or some other number, I know that no matter what, my y, at the y-intercept, that x equals 0. Does that make sense? I know that wherever this parabola crosses, whether it goes like this, or if it goes, like this, I'm not sure yet, but I know that it's going to cross the y at some point. And I know whenever it crosses this y, at this point, the x value is 0. And because I know that, so what I'm going to do is I'm going to evaluate the function at 0. So instead of x, I put 0. And instead of x squared, I'm going to put 0 squared. And instead of -4x, I'm going to put -4 times 0. and then this stays the same plus 5. We learned how to do this in semester in MP2, in marking period 2, so like before Christmas, so it might be a while. We evaluate the function at 0 because we want to know what does y equal when x is 0. 0 squared is 0, minus 4 times 0 is 0, so you have 0 plus 5, and at the end our f evaluated at 0 is 5. So what that means is, remember, f of x can also be written as y, so that means our y is equal to 5. So at this point we have x equals 0, y equals 5. So we've got 2 points now, our vertex and our y-intercept, and we know that these repeat across the axis of symmetry, so we're just going to draw this. Once we get one half, we know what the other half is going to look like. Okay, so I'm going to kind of repeat what we did. Ooh, I erased too much. My parabola. What happened to my parabola? I was trying to... First, I rewrote this equation by completing the square so I could make it look like this equation. And then to find the vertex, I wrote it this way so I can use the h and the k to find my vertex. And then I evaluate this equation at 0, at x equals 0, to find my y-intercept. I'm going to go through the process again in this example, and let's see if it makes a little bit more sense. Okay. Instead of doing all that process, we're going to see how can we find the vertex when we have the function in the formula when it's already like this, right? So we had to go through all that steps, rewrite it, and then try to find the vertex. But good news, there's a formula. And that formula is, it's actually a parentheses. This is going to be a coordinate point. So there should be parentheses here. Your x is going to be negative b divided by 2a. And your y is going to be the function evaluated at whatever your answer is here, whatever answer you get here is going to go in here. Okay, so let me show you kind of what that looks like. It's not all that complicated. So remember, you have y equals ax. Let me write it in, let me do different colors so it makes a little bit more sense. Remember, f of x is the same as y. Ax plus bx plus c. Okay, so in this case, our a is 4, our b is 4, and my c is negative 3. So I'm going to use this equation for my vertex. Negative b divided by 2a. So for b, I'm going to put 4. Keep the negative sign, change that to a 4, just keep the 2 the same, and my a is right here is going to be also 4. Let me make it red so I match the color. Okay, and the second coordinate part, the second part of the coordinate point, which is your y, is going to be this function evaluated at the answer for this. Okay, so negative 4 divided by 2 times 4, which is 8. That's going to be 4. Let me write it out this way. So the first number is going to be this little calculation, and then it's the function or the equation evaluated at the answer for this. Okay, parentheses. So what that means is negative 4 divided by 8 is going to be negative 1/2, comma, we're going to take the function evaluated at -1/2. Okay. Let me, I'm kind of running out of space, so I'll just keep writing. We'll look at the y-intercept here in a little bit. So what that means is our x value for the vertex is -1/2. Okay. So we know that we're going to have x is at -1/2, but we got to figure out where our y is. Okay. So we're going to evaluate this function at x equals 1/2. So the function is 4x squared plus 4x minus 3. And what I'm going to do is everywhere there's an x, I'm going to put a -1/2. So here instead of x, I'm going to put 1/2. Okay. And then I'm going to solve this equation, and that's going to give me my y value. Okay, so I know it's a lot of steps, but 1/2, I'm going to do -1/2 squared, which winds up becoming 1/4. We learned that in working with rational expressions. Plus 4 times 1 is 4, divided by 2 is 2, minus 3. This 4 and this 4 cancel each other out to leave 1. So your final answer is 1 plus 2 minus 3, so it's 1. And 2 is 3 minus 3 is 0. So when we evaluate the function at 1/2, we get 0 for our y. Okay, so this is our answer for this. So my vertex for this one is actually at 1/2, 0. But how do we graph it? Well, we need to know what the y-intercept is. So remember, I told you guys that we can find the y-intercept. Now I'm kind of like going to block this off here. The y-intercept we can find when we substitute for every x, we substitute in a 0. Okay, so I'm going to take the same equation, but everywhere there's an x, I'm going to put 0. That goes to 0, that goes to 0, and I'm left with -3. Okay. So what that means is my y-intercept is at x equals 0 and y equals -3. Okay, I made a mistake because it can't, if I graph this, it would be pointing downward, it needs to be pointing upward. So let's look right here, okay? Right here I made a mistake. Instead of multiplying by 1/2, I should have multiplied by -1/2. So let's fix that. Then that becomes -2. And this still becomes 1 minus 2 minus 3, which is 1 minus 2 is -1 minus 3 equals -4. So my vertex is actually -1/2, -4. And then my y-intercept is still 3. That makes more sense. Okay. So my graph's going to look like that. My x-intercepts are here and here. Okay. So just like how we kind of did the f of x, you know what? Let's not worry about the x-intercepts. Okay, let's just leave it at that. We know it's pointing upward, which matches up with our +4 here up in the A, and we know that we have a parabola with a vertex at -1, -4 because we used the formula and we didn't have to rewrite and convert that formula. Okay, so what you're going to do for the practice is you're going to practice rewriting, but actually I don't think we need to do that. Let's not worry about rewriting. What we're going to do, you do need to. Okay, so there's two ways. Here's what I know now. I know what I want you guys to do. There's two ways. You can either rewrite the formula by completing the square, or use the vertex formula to find the vertex, and then set the function equal to 0 to find your y-intercept. So what that means is everywhere there's an x, you'll put a 0. And that will give you your y equals the answer. Okay, and remember, in this case, our a is 1, our b is 6, and c is 5, but we don't need that for the formula. The vertex is minus b over 2 divided by a, and then we have to evaluate the function at whatever answer we get here goes here, and we plug that into our x values and then solve that. Okay. So if you need some assistance or some help with the steps, rewind the video and rewatch all of this part again. Okay, and it'll explain it again.